Dark comets are fascinating and puzzling objects in space. They look a lot like asteroids, but they behave more like comets. This unusual combination challenges what we think we know about our solar system. Unlike the bright tail-waving comets that we often see in textbooks, dark comets do not have visible tails or release gas. However, their movements suggest that something interesting is happening with them. We will dive into the science behind dark comets, their possible connections to Earth's history, and why astronomers are so excited about discovering them. Dark comets are not your average space objects. They are a mix of asteroids and comets. Scientists first identified these mysterious objects just a few years ago. They show a unique behavior called non-gravitational acceleration, which is a common feature of comets. However, dark comets do not have the visible tails or outgassing that we usually associate with comets. This strange characteristic has led scientists to place dark comets in a category of their own. Astronomers have identified two main types of dark comets: outer dark comets and inner dark comets. Outer dark comets are larger, measuring hundreds of meters across, and have elongated orbits that resemble those of Jupiter family comets. On the other hand, inner dark comets are smaller, usually only tens of meters wide, and follow nearly circular orbits in the inner part of the solar system. Scientists were able to make this distinction by studying the orbits and reflectivity of these objects. Traditional comets accelerate because they release gas and dust when they get close to the Sun. This process, called outgassing, happens when volatile materials like water ice vaporize, creating a push that propels the comet forward. However, dark comets do not show any visible signs of outgassing. Some early theories suggested that their rapid rotation might cause material to be ejected from their surfaces, but this idea has not been confirmed yet. What is clear is that the behavior of dark comets challenges the simple classification of comets and asteroids, highlighting the need for a deeper understanding of the objects in our solar system. One of the first identified dark comets is called 2003 RM. Its orbit and subtle acceleration could not be explained by gravitational forces alone. This discovery led scientists to realize that many more objects like it might be hiding in plain sight. So far, researchers have identified 14 dark comets, which has allowed them to start piecing together their story. Dr. Dahl Seligman and his team at Michigan State University analyzed the reflectivity and orbits of these objects, doubling the number of known dark comets from 7 to 14. They found that dark comets can be divided into two distinct categories: smaller inner dark comets with circular orbits, and larger outer dark comets with elongated orbits similar to those of Jupiter family comets. The origins of dark comets are just as mysterious as their behavior. One popular theory is that these objects are remnants of comets that have lost their volatile materials after making close passes to the Sun over time. As these comets lose their icy materials, they may start to look more like asteroids while still retaining some comet-like dynamics. Outer dark comets likely originated in the far reaches of the solar system, possibly in the Kuiper Belt or the Oort cloud. These regions are filled with icy bodies, and gravitational interactions with giant planets like Jupiter could have redirected some of them into shorter, more elliptical orbits. Inner dark comets, on the other hand, may have evolved from main belt asteroids that underwent changes due to collisions or thermal effects. The orbits of dark comets often show slight deviations from what we would expect based on gravity alone. These deviations suggest that there are additional forces at play, such as outgassing or the shedding of material due to rotation. For example, the Yarkovsky effect is a phenomenon where sunlight heats one side of an object, causing it to emit radiation unevenly. This could potentially influence the orbits of dark comets, but the exact mechanisms are still being studied. One of the most exciting ideas is that dark comets may have played a significant role in delivering water and organic materials to Earth, which could have been crucial for the development of life. Objects like 2003 RM, along with other Jupiter family Dark comets such as 2015 KH162 and 2006 RH120 showcase the potential diversity of these objects and their possible contributions to the evolution of planets. As of now, 14 dark comets have been identified, including some that were initially thought to be asteroids but were later reclassified due to their unusual acceleration patterns. The idea that comets brought water to Earth is well established, but dark comets add a new layer to this story. Unlike traditional comets, which are easier to spot and study, dark comets might represent a hidden reservoir of volatile materials. Their elusive nature makes them harder to detect, but it also means they could have contributed to Earth's development in ways we are just beginning to understand. Beyond our planet, dark comets may have transported life-building compounds to other celestial bodies. For instance, their potential to deliver organic molecules and water to icy moons like Europa or Enceladus raises exciting possibilities for the search for life beyond Earth. These moons could provide environments where life might emerge or where existing microbial ecosystems could be sustained. Missions like NASA's Near-Earth Object Surveyor aim to identify and study these intriguing objects in greater detail. By understanding their composition and behavior, scientists hope to gain insights into the processes that shape our solar system and how they might influence the emergence of life on Earth. The connection between dark comets and interstellar objects opens up new avenues for research. Both types of objects exhibit non-gravitational acceleration without visible outgassing, suggesting that they may share similar processes. Studying dark comets could provide valuable information about planetary systems and interstellar visitors, such as Oumuamua, offering clues about material exchange and the search for life beyond our planet. Dark comets are more than just a curiosity. They are a window into the history of our solar system and a reminder of the dynamic forces that continue to shape it. By studying these mysterious objects, we not only learn about the past, but also prepare for the future, ensuring a deeper understanding of the universe we inhabit. Don't forget to like, share, and subscribe for more exciting explorations. See you next time.